Okay, hello viewers. Welcome to this video lecture. Today's video lecture is all about periodic properties. All about periodic properties. The basic lecture is the basic lecture for CSIR, NET, and GATE. Right. This is the basic lecture. So we'll discuss periodic properties. Before that, we will discuss first the location of electrons. Location of electrons. The location of electron is in orbitals. Okay, and the orbitals are present in various subshells. Clear? And the subshells are present in shells. Okay. So to define the shells or subshells or orbitals for the location of electrons, you need to define four quantum numbers. Represent like NLMS. It represents N represents principal quantum number. Clear? And this L represents azimuthal quantum number. M represents magnetic quantum number, and S represents spin quantum number. Clear? And now you have to remember these three. It is dependent on Schrödinger wave equation. Schrödinger wave equation, where it is independent of Schrödinger wave equation. Independent, right? So what happens in this process? You have to detail study about principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number to define the location of electrons, and similarly you will define SPDF like four orbitals, and you will define SPDF four subshells, and you will define K, L, M, N, and so on, right? These cells utilizing these four quantum numbers. So we will discuss four quantum numbers. Before that, we will explain that first one, that is principal quantum number. Okay, this is principal quantum number. Okay, so principal quantum number is represented by symbol small n. Okay. So what it defines? It defines number of cells. Okay, utilizing this value, you will know the Bohr radii. The Bohr radii can depend like this: Rn is equal to 0.529 n square by Z effective, and unit is angstrom. Similarly, you will define the electrons in nth orbit or shells, right? This represents nth orbit or shell. Clear this point? And for the n value 1, the orbit or shell is K. For n value 2, this is L. For n value 3, this is M. For n value 4, this is N, and consecutively this increases, right? But we study only four orbits or shells, that is K, L, M, N. So therefore we only focus these four quantum numbers. It's known as principal quantum number. It represents its respective shells, that is K, L, M, N, right? So you will define the nth orbit. Suppose this is V1, or it may be V2, V3, whatever it may be. So accordingly you change this value, and Z is effective nuclear charge. So similarly, for velocity of electrons, which is revolving around nth orbit, the value is 2.18 into 10 to the power 6 Z effective by N. The unit is meter per second, right? Similarly, for energy in nth orbit, the energy of electron nth orbit is called minus 13.6 Z effective square by N square. The unit is in electron volt. Okay, where N starting from 1, 2, 3, 4 up to infinity. up to infinity. Now the question arises. Number of shells in an element. Number of shells in an element. Number of cells in an element. What is your answer? Okay, you can't say 4. You already studied K, L, M, N. Don't say like that. Number of shells in an element is infinitive. The answer is infinitive. Infinite. Okay, because n value starting from 1, 2, 3, 4 up to infinity. Similarly, you will define K shell, L shell, M shell, N shell. K, L, M, N. Suppose what happens? Suppose you take hydrogen. Okay, hydrogen, the electron configuration is 1s1. This is electronic configuration, and you know that this hydrogen contains 1 electron. It is in 1s subshell, or it is in K shell, or it is in K shell. But you have to remember one thing, that the electron is in K shell, but the element contains the electron is in K shell. But if you ask how many shells in this element, the answer is obviously infinitive. The reason is like this. So this is 1s. Okay. Suppose you excite this electron, it will jump to another shell. Suppose you excite this one electron to another shell, it will occupy another shell. So similarly, if you excite these electrons, you will find new shells. So therefore, this exceeds from 1 to infinity. There is no fixed shells. In an element, but for we study purpose, we only discuss these four shells. And for this, suppose we talk about hydrogen, we say this is in 1s, or it is present in one shell. When it is, we will talk about only ground state. For excited state, the electron is not in one shell or two shell or three shell. It is in number of shells, therefore infinite for an element. Okay. Now we'll discuss azimuthal quantum number. We'll discuss azimuthal quantum number. Okay, so we'll define azimuthal quantum number. Okay, it is represented by small l. Okay, when n represents number of cells, it represents number of subcells. Clear this point? Number of subcells. Okay. So L value starting from 0 to n minus 1. Okay. Now what happens? Suppose you take n is equal to 1. So value of L is equal to 0 to n minus 1. That means 0 to 1 minus 1. That means 0 to 0. Obviously there is no 0 to 0. Between 0 to 0 there is no extra value between there, it's only 0. So for n is equal to 2, the value of L from 0 to n minus 1, that means 0 to 2 minus 1, that is 0 to 1. It is only 0 and 1. Clear this point? Now what happens? For n is equal to 3, the value of L 0 to n minus 1, that is 0 to 3 minus 1. That is 0 to 2. And in between 0 to 2, you have 1, 0, 1, 2. The value of 1, the value of L is 0, 1, 2 for n is equal to 3. Now I have to define only one thing. Number of subcells defined by this quantum number, that is known as azimuthal quantum number, and it started from 0 to n minus 1. Clear this point? For n is equal to 3, the number of subcells is obviously 3. For n value 3 it is 3, for n value 2 it is 2, for n value 1 it is 1. That means the number of subcells for nth shell, the number of subcells is equal to n. For first shell, because this represents the shell, for first shell you have only one subshell. For second shell you have two subshells. For third shell you have three subshells. Clear this point? Now the question arises, if the value increases like this, okay, if the value increases like this, okay, so here number of subshells n. for n value 0 to n minus 1. For n value 0 to suppose n minus 1, that means what happens? 0 to n minus 1, suppose it is 0 to n, that means one extra value n. You know that 0 to n minus 1, the number of subshell is equal to 1. Now you have extra subshell here, the value is n plus 1. For L value 0 to n plus 2, what happens? 0 to n minus 1, this is n plus 1. The value is 0 to n minus 1. You have number of subshell is called n. Now you have extra 2 values, so the number of subshell is called n plus 2. So we'll ask you a question. Find the number of subshells. Find number of subshells. Find number of subshells. Okay. Find number of subshells in fifth cell. In fifth cell, if value of L varies from 0 to n minus 1. Okay, n plus 1, sorry. Answer is from 0 to n minus 1. Okay, from 0 to n minus 1. So number of subshell is equal to n, right? Now what happens? 0 to n minus 1, then n plus 1. What happens? You know that the value of n increases by factors 2, that is n plus 2. Clear this point? For fifth cell, the value of n is equal to 5. Now what happens? For 0 to n minus 1, number of subshell is equal to 5. For n plus 2, number of subshell is equal to 7, where n is equal to 5 also. N plus 2 is equal to 7. We clear this part. Okay, now we will discuss Aufbau principle. Okay, we will discuss Aufbau principle. Okay.